fundamentally we're experiencing things from within ourselves. As we gradually can extend our senses, can extend our view of the world, we're sort of gradually expanding our minds to the point where we can encompass more about what's possible and what's happening in the world. I think one of the, again, sort of Pyrrhic things that has to happen is, by the time, if we could extend sort of throughout the Ruliad, if our minds could span this whole Ruliad in a way that's like, wow, we made it. We span the whole Ruliad. Problem is, I don't think we coherently exist at that point. I think that coherent existence is a feature of the particulars of some entity that has some sort of set of coherent characteristics. By the time we are everything, we're in a sense, almost definitionally, we're nothing. By the time we span everything, we don't have a sense in which we are these individuals, we are these entities that we can identify as coherent things.
This is Daniel Fagella, and welcome to The Trajectory. This is the 22nd episode in our Worthy Successor series, and it would be impossible to have a series about the future blooming and unfolding of complexity and life into the cosmos beyond humanity without speaking to the king of complexity himself, the man of Rule 30, Stephen Wolfram. Stephen was on one of my other shows about 4 years ago. Stephen's obviously given great deal of thought to the great, complex, and unfolding process that we're all enmeshed with, and has also thought a great deal about artificial general intelligence. How much progress are we making on it? Where are we headed towards it? And maybe where should it take us? And that is where this conversation gets absolutely wild, in my experience. So we go a little bit into Stephen's sort of read on the latest waves in technology and sort of how he's thinking about those and how they fit into the bigger picture of general intelligence. Lots of interesting stuff there. And when we start to lean into what should intelligence unfold into, in other words, what is this all transforming and sort of changing to, and what should it change to that might lead to kind of a good future for the cosmos or for life versus a bad one, we land in a wild place. There's no other way to explain it than this is an absolutely unique episode here on The Worthy Successor in many different regards. The way Stephen orients himself in the questions is completely different from anybody we've interviewed, which was refreshing in many ways and also required me to really kind of keep up and figure out where he was coming from. But it was incredibly unique as an experience, and there's a couple very big takeaways I have for the end of this episode. So without further ado, I'm going to let us fly into this incredibly unique take on sort of the future of moral value and the unfolding process of life with none other than Stephen Wolfram here on The Trajectory. So Stephen, welcome to the show.
Thank you.
Glad to be able to dive in on sort of the future of life, trajectories, unfolding complexity. I'm going to get into the normal Worthy Successor questions that our audience is going to be familiar with from the other great thinkers we've had on. But there's a lot of table setting with your worldview around computation and sort of the nature of the complex and unfolding process through the Ruliad space lens of which you often orient us in your writing. I want to kind of get into a few questions that I think would help to set the table for people that are maybe familiar with your work but want to know how it would apply to certain things. Often you're sort of discussing the system of living creatures kind of unfolding and acting in a way that's very similar to what you suspect that non-biological creatures would. In other words, there's an equivalence, computational equivalence, et cetera, of sort of substrate independence for what complexity is. And many people who've come on the show have sort of opinions of what bio-life versus non-bio-life would be able to do. I wonder, there's maybe a tertiary explanation of why you see so much potential unity undergirding it, and if there are distinctions of what, at least as of today, you see the bio world outstripping the digital world in, and vice versa, just to help people understand your take.
So let's start from the beginning. The sort of great paradigm, I think, of 21st century is this idea of computation. We're somewhat familiar with it because we use computers all the time. But what sort of intellectually, foundationally is computation? I think the core of it is you set up rules by which some system operates, and then you just run with those rules 1 billion times, 1 trillion times, 1 quadrillion times, whatever. It's all about kind of the unfolding of things from potentially very simple rules. So sort of the big discovery that I made in the early 1980s is even when the rules are very simple, the things you make can be very complicated.
Emergence, yeah,
That was something that was very surprising to me. It kind of was an intuition breaking thing. It's something you discover very quickly if you start actually doing experiments in the kind of computational universe of simple programs. And it's something where, given that new intuition, I mean, our traditional intuition is you want to make something complicated, you've got to go to a lot of effort, you've got to set things up in a very complicated way. That's how you make complicated things. The big surprise is in the computational universe, that's not true. You can have extremely simple rules that when you run them, do very complicated things. So that's kind of the zeroth kind of story that we start from. I think, one of the things to understand there is what does it mean that something does complicated things? And, one way to think about that is if you know the rules for a thing, you might assume that knowing the rules, you can kind of say everything about what the system will do. And that's kind of the conceit of traditional reductionistic science, that it's all about kind of drilling down to find the underlying rules, and then you're done. Well, the surprise is that, you can take these rules and run with these rules. And then the question is, can you jump ahead and kind of outrun the rules and say, given these rules, I know what the system is going to do? Or are you stuck just having to follow one step at a time, just like these rules do? And that's this phenomenon I call computational irreducibility, I think is important for many, many purposes. Please.
Yes. Okay. So this is we're diving into where we need to go here. Obviously, there's kind of the emergence idea. People are familiar with your Rule 34, 31, the famous one that evades me now.
Rule 30, yeah.
Yes, Rule 30, yeah. And then we've had I think there's an increasing, maybe through your work and some other thinkers that I think have shown light on this. I think there's an increasing appreciation of how even something as simple as bubble sort might manifest sorts of perturbations and behaviors, quote unquote, that would be wholly unpredictable regardless of how short the actual code is.
Bubble sort is a bit challenging to make that argument about, but there are plenty of very simple algorithms.
Michael, it's Michael Levin's example, not mine. I'll let you guys take up the argument there. I'm just the guy that interviews people.
That's not a good example, but there are things very close to that are good examples.
I'd gladly watch the debate. Regardless, you get what I'm getting at. There's a number of spaces where I think more people are amenable to the notion that sort of grand complexity and emergence sort of spins out of these systems. I wonder, for you, again, the tie-in here is that biological or otherwise, that same space of rules that can be run in many ways should be able to unravel, permutations of complexity just the same, almost sort of substrate independent, so long as it can kind of do computation in some way, shape, or form. The substrate independence.
Couple more steps to get.
Go ahead. Yeah, lay it on us.
We're kind of first of all talking about kind of the raw phenomenon of simple rules do very complicated things. Simple rules can be unpredictable in the sense that the only way to know what they'll do is just follow each step and see what happens. That's the computational irreducibility. Yeah. That's stage zero. Now, a thing to say about that is, I agree that after 40 years of kind of talking about this, there is an increasing emergent understanding of the phenomenon of kind of complexity emerging from simple rules. I think it is surprising the extent to which one doesn't get that until one's actually tried doing the computer experiments oneself and tried to say, I think I know what's going to happen. Then you actually try it. And as I often say to people, the computational animals are always smarter than we are. I'm still, after 45 years of doing this kind of thing, it's still, I study these things quite often. And even last few days, I was studying some particular kinds of systems where I'm pretty sure it can't do this. And then you actually run it, you search through the space of possible rules and so on. And it's like, well, actually, it managed to do that in this very unexpected, very kind of clever seeming way. So it's an important kind of, the intuition that very simple rules can do very complicated things is a surprisingly unfamiliar intuition to us. But that's kind of the beginning of the story. So then, the next question is, one can kind of go into what does it mean that very simple rules can do very complicated things? what does that mean for our experience of the world? Well, a thing that was sort of a big breakthrough for me about 5 years ago was figuring out things about how fundamental physics works and how kind of for our whole universe, there can be a simple rule that generates sort of all the complexity that we are used to in the physical world. But one of the things that's sort of notable there is kind of when there is computational irreducibility, things become very unpredictable. Yet one of the very notable features of the physical world is that there are physical laws which are somewhat predictable. We kind of know that we can define laws of mechanics or something where we can expect if we, throw something out in space and it will just keep going in a straight line. It's something where we can predict what's going to happen. There isn't computational irreducibility in aspects of what we see in the physical world. So one of the surprises is that there are physical laws which make things predictable. There are sort of reducible features of the world that don't get mired in this computational irreducibility, which is the generic thing that happens with simple programs. And so one of the things to realize, and this is sort of a bigger picture, is that within any computationally irreducible system, there are always an infinite number of pockets of computational reducibility. In other words, even though you can't say everything about what the system is going to do, there's certain things you can say, and there'll be an infinite number of things you can say. And that's why, for example, if we're doing mathematics, there's an infinite number of theorems we can prove. If we're kind of inventing things, there's an infinite number of inventions we can make. Even the sort of the underlying substrate is computationally irreducible, but there are always these pockets of reducibility, an infinite number of them that we can find. And so, for example, for us existing in the physical world, we kind of plug into a certain set of pockets of reducibility. Those are the things that are our perception of how the universe works. Those are the things that lead to our laws of physics and so on. So that's kind of the picture of what's happening in physics. Now, how does that relate to biology, for example? The thing that I had worked in the 1980s trying to understand kind of how things like biological evolution worked. I didn't manage to get it to work at that time. I was interested in how you could go from sort of the simple rules represented by some kind of minimal genome to the kind of complexity that you see in actual biological organisms. I tried to kind of get the genomes to evolve in some kind of adaptive way to make sort of different kinds of organisms. Didn't get very far with that. Well, came back to that actually last year with one important new piece of intuition, which is the experience of machine learning. The big surprise of machine learning that became particularly clear in 2011 was if you bash a neural net hard enough, it will learn all kinds of things. It wasn't obvious that running it for a month on a GPU, it would suddenly be able to recognize images. The toy versions of that problem, which I had worked on back in the 80s and so on, it didn't really work at all. So the thing to realize is that, if you bash the system hard enough, surprising things will happen. So given that new intuition, I started looking at these very simple kind of idealized biological systems and found out if you bash them just a little bit harder than I bashed them in the 1980s, well, by golly, they actually managed to adaptively evolve just like kind of the systems that we see in biology. And so then the question is, well, why does that work? Why is it the case that given some fitness criterion, like, you might have some pattern where you say, make the pattern live a certain amount of time, or some other criterion like that, or make the thing be a certain shape or something. Why is it the case that within this sort of space of possible computational rules that you can find one that does that and that you can get to it by making these little mutations, little adaptive changes to the rules? Why is it that you can follow this path that succeeds in getting you to achieve some particular objective? So the answer to this turns out to be closely related to computational irreducibility. And really, in the end, the answer is that the kinds of fitness criteria that we are interested in using in biology, which amount to, are you a successful organism that can have lots of children? The kinds of fitness criteria we use there, which is similar to the kinds of criteria we use in machine learning, can you recognize a picture of a cat from a dog type thing? These are, in a sense, very coarse criteria for success. And it turns out that it's the interplay between sort of the sophistication of this irreducible computation underneath and the comparative coarseness and simplicity of the objectives that we have, that's what makes biological evolution and machine learning work. And it's something where you could say, well, how does it work? Tell me the mechanism by which it works. And that's so an example would be, let's say your objective is, build a wall. Well, one way you can have a mechanistic explanation of what's going on is say, I'm going to make a bunch of bricks. I'm going to arrange the bricks in a certain very regular pattern. That's the way I'm going to build my wall. That's sort of the traditional engineering approach. What happens in both machine learning and biological evolution is instead, it's like you're picking up these rocks off the ground that are all sorts of different weird shapes. Those are kind of lumps of irreducible computation. And it just so happens that you can put together these lumps of irreducible computation to achieve the objective of building a wall. I mean, around New England, where I am, and I know you've been in the past,
yes.
There are lots of stone walls.
Absolutely.
You look at these stone walls, and there are all these rocks that are put in there.
Weird
and they
shapes.
more or less fit. But if you ask the question, what is the mechanism by which this wall is built up? What is the, is it a precise bricklayer pattern? What is it? No, there's no such mechanism. It's just these rocks happen to fit together to achieve the fairly coarse objective of building up this wall.
Yeah.
And that's kind of the way to think about, I think, both biological evolution and machine learning.
Okay, there's a lot to get into here. The idea here is that the just almost unboundedly, bounded within pockets, but otherwise unbounded degree of complexity within sort of the total computation space, contrasted with this extremely coarse sort of thumbs up, thumbs down, does it cut the mustard set of rules, is what on some level builds the higher levels of emergent complexity. In other words, the things that pass that filter get to have the chance of combining, turning into bigger lumps, more complex lumps, and they're again going to pass the same filter, right? The flatworms we evolved from. Go on.
I'm not sure that's quite right. I mean, I think that the way to think about it is, what is our definition of success for biology or for machine learning?
Sure.
It's a very coarse definition of success. When we look at how that success is achieved in, for example, biological organisms, we see all of this complexity in these organisms. When we look inside an LLM, we see all sorts of complexity, very hard to understand patterns of things. We can't say what's going on. Now, are those complicated ways to achieve things, are they the only way to get to this end result of this kind of fitness, achieve fitness? The answer is probably no. But they're the way you get there if your raw material is computation. Your raw material is irreducible computation, and your mechanism for getting there is adaptive evolution. That's what you end up doing. You end up fitting together these sort of misshapen rocks in a way that happens to build up the kind of thing that you want to achieve. I mean, it's probably the case if you were, if your definition of what you want the humans to do, so to speak, is some very specific thing. You want the humans to, the great achievement of humans might be, build a tall tower. Well, you can have a much simpler system that will be really good at building tall towers. It's not, it doesn't have to go through all of this kind of, raw material of computation, sort of adaptive evolution, all that kind of thing. The fact is, and then we say, well, what tends to happen in biological evolution and actually in machine learning as well is these systems get built up. They are built from these pieces of irreducible computation. They were built for a particular purpose, but it turns out they do all kinds of other things as well. And when we say, well, why do they do those other things? Why does it work that way? There isn't really a good answer to that. It's just this irreducible computation happens to have this or that feature. I mean, we see this a lot. If we're asking questions, in my studies of sort of the minimal models of biological evolution, you build up these things that are kind of minimal idealizations of biological organisms. And then you can ask the question, well, how do you describe what's inside these things? They're very complicated. They're actually complicated in ways that sort of mix things that seem like little regularities with things that kind of are complicated ways those are glued together. It's kind of funny, if you ask an LLM to, describe one of these pictures, it will write a description that reads very much like typical descriptions that you would find in medical textbooks. It's like it's the this structure, is proximal to that structure and does this and that and the other. And in medicine, there's no reason for it to, quotes, make any sense. People can say, well, it is that way because blah, blah, blah. But really what's happening is that is a thing that was a solution, one of an infinite number of possible solutions, that was the one that the history of biological evolution chose. And it happens to be a rather ornate solution because that is what most solutions are. And that's, that's the thing that we get dealt as the way that we humans actually turn out to be. And it's something where it's not the case that, we're building up these structures. You see in these kind of simple minimal models of biological evolution all the time. You see at one stage in the kind of idealized fossil record, you see the system figured out some particular way of doing something. It figured out you can make purple triangles that have borders of this. Then you see, it goes on in its process of evolution. And then, in 10 million years of conceptual time later, it's figured out that you can stack, purple triangles on top of each other in little blocks, and then that lets it do something else. You see the same kind of sort of breakthroughs get made and then built on that you see in the history of biological evolution and the fossil record and so on. You see that same kind of thing happening in these very idealized computational systems where you're sort of fitting together these lumps of computational irreducibility and building these sort of taller towers of capability. Now, I have to say there's things about that process we don't yet understand very well. We happen to be really working on that quite hard right now to try to understand kind of this notion of how discoveries get built on. You can see discoveries get made in these simple computational systems, and there's kind of this question of sort of what's the kind of meta theory of discovery that can be built on, that goes from, you have this thing that serves like one kind of organ, and then you can build on that to get another kind of thing, and so on. We don't yet understand that terribly well. And the result, the sort of final thing that gets built has these kind of pockets of reducibility that seem to be important in being able to build the sort of taller tower. But even the fitting together of those pockets of reducibility is something very messy and complicated. And this is true both in biological evolution and in machine learning.
Yeah, well, I think it's clear that you're taking a pretty firm crack at sort of the nature of intelligence, the nature of this emergence process. And to me, as we start to build things that are extremely powerful, AI is, I don't know if it's been 5 years since we had an interview or something, but I mean, even in that time, and we have a whole new set of magazines of powers of these systems. And I presume in another 5 years, we'll be even further down the line. It feels like asking, is this stuff proxying off of the greater intelligence process that it seems like we're part, the unfolding, unraveling process of which we are part? Let me ask this question. I'll get into a couple more because I'm going to get into sort of some of your trajectory ideas into the future, and then we'll get into some of the meat and potato questions. But this is great groundwork here from your vantage point. When you think about, Lord knows how many thousands of years, hundreds of years, doesn't matter, into the future, wildly complex entities existing in different parts of Ruliad space than we presently have access to, that are biological, non-biological, whatever, are ripping forth into the galaxy, doing things for which you and I have no words, just as sea snails would not understand the conversation I'm having with you. As that occurs, is it, to you, do you expect it to still be primarily a bunch of irreducible computation stuff, coming together in bigger and more complex combinations of shapes, coming up against the same filter, crude filter, whatever your word was, crass filter of does it replicate? Does it keep itself alive? Does it persist? Now, the machines may not be mating in the same way we do, but they may be replicating. They will be persisting. Do you suspect that the unraveling of this complexity, even when it's non-biological, will essentially be that yin and yang you've articulated, or something different?
Well, I think in the end, it's a bit of a Pyrrhic victory, because I think what happens, the thing to understand is there's lots of computation going on in the universe. Some of it happens in human brains. The stuff that happens in human brains that we're very proud of, that we think of as being sort of consciousness, minds, yes, all that kind of thing, it's actually a rather special kind of computation. it's not a very general kind of computation. It's actually a kind of computation that's restricted relative to the kind of computation that happens elsewhere in the physical universe. So I think the thing to understand is, there's lots of computation already happening. As people say, the weather has a mind of its own. There's all these physical processes going on in the atmosphere or something that are just as sophisticated as the physical processes going on in brains. They're not very similar to the ones going on in brains. The ones going on in brains have a very particular pattern. I mean, the ones going on in brains have the following pattern. We take in lots of sensory data, gigabytes per second, roughly, of data comes from our senses, then goes into our brains, it rattles around. In the end, maybe 10 times a second, we decide, what are we going to do next? What muscle are we going to move in our throats to say something, or our hands to gesticulate, or whatever else. So what's happening is, brains are doing this thing of taking lots of sensory input and kind of grinding it down to a stream of actions. And that's the particular thing that seems to be special about how we think about ourselves. We have this thread of experience that comes from, we have all the sensory input, we integrate it into this one kind of thread of experience that's what determines how we act. And I think that that kind of condensation of sensory input and so on, it's not, other computational systems don't necessarily do that. The weather doesn't do that. The weather has as much more sophisticated computation than happens in brains, but it doesn't happen to have computation that has that pattern of action. But that pattern of action is important for kind of a human-like mind experience. And, we can ask, why did we evolve that way? Probably we evolved that way for an incredibly mundane reason, which is, if you look at life, which didn't have animals that moved around, there's no reason to have this kind of condensation of action.
Absolutely.
It's like one piece of the big stromatolite can do one thing, and another piece can do another thing. It doesn't have to have kind of global communication. When you can move around, you have to decide, you're going to go left or you're going to go right. There has to be something which takes all that input and makes a single decision out of those things. So this kind of vaunted capability that we have, that we're very proud of about how minds work, probably comes evolutionarily, a couple of billion years ago, from that very mundane need. Now, the question is, as we go on and we build systems that are doing computation, computation is sort of cheap in the physical universe. There's lots of systems that do it. There's a question of how aligned the computation is with the kinds of things that we do with our minds. That's one question. But the question of, is there sort of greater computation that can be done? Absolutely, there's greater computation that can be done than happens in brains. It's happening all over the physical universe. And what does that feel like to us? Well, most of what happens in the physical universe is very hard for us to understand. It's full of irreducible computation. We just can't really get a handle on it. Most of it, we kind of shrug and say we don't really care about that. We don't care about the details of how those pattern of molecules in the cloud were moving around to do this or that. It doesn't really matter to us. It doesn't matter to our lives. And so I think the thing to understand about sort of the future of, if you imagine kind of the future civilization of the AIs, so to speak, it's all about lots of computation happening, much of which we'll kind of shrug about. It's kind of like, there's all this computation going on. It's a bit like what happens in the natural world. So what, so to speak? What we tend to care about as humans is what happens, what we perceive in our minds, what we can kind of hold in our minds. I mean, already today, there are surely more AIs than humans by most counts in the world. And there's lots of, the AIs are interacting with AIs, and there's a whole kind of civilization of AIs selling ads to each other or whatever else they're doing.
And mostly that.
And the thing is that all of that computation that's going on, all of that sort of sophistication that's happening there, it's like, that's happening. Doesn't really matter that much to us. Just as the natural world, we can say the same thing. There's all that computation going on, doesn't really matter that much to us. And I think that's part of the thinking about sort of the what does it look like when sort of everything is computational like that? Well, it already is in nature. I mean, one thing to say to get a little bit of understanding of the trajectory of these things, right now, when we make stuff, we we often use materials that are artificial materials that last 100 years. We've had plastics and all kinds of things which are not things that sort of naturally occur in the world. They're things that we make by chemical processes. What we don't yet have is kind of molecular scale computation in the things we make. So in other words, the things we make are made of artificial materials, but they're not, it isn't the case that everything is made of computers. For the things that we deal with technologically, that we manufacture, we are dealing with things that might be artificial materials. The molecules are arranged in a way that was set up by some artificial process, but it's not like we're making things out of computers. There's one exception to that, which is biology does effectively make things out of computers. I mean, we as biological systems are the only known example yet of a kind of molecular level computation going on in a way that sort of fits together to produce something that seems to do something useful, so to speak. In other words, right now, it's, to the future, in the future, the idea that I have a glass of water and my glass of water is just glass and it's not glass that is computing, that will seem very kind of old-fashioned, just like it would be very old-fashioned to say the only materials I can make things out of are things that I can pick off the ground, like pieces of wood and so on.
Yes.
The concept but there is an example, which is biology, where there is molecular scale computation going on, and so I think that's kind of the thing to start to understand is what's happening in that molecular scale computation that biology is already using. And it's different from, in a computer, we have, feature sizes of tens of nanometers and so on for wires, but it's very, it's a two-dimensional structure. It's kind of laid out like a giant city grid. And, it's set up at that level. One can imagine something where, well, it's actually just every molecule for itself. Every molecule is being part of the computation. That's not yet what we can achieve in digital technology, but that's something that biology has achieved. And so one of the things I've been interested in recently is how was that achieved in biology? What's really going on there? What's the general category of thing that's happening when you have this kind of molecular scale computation going on? And what the thing to understand is when you have, your plastic mug or something, the molecules in your plastic mug are just sitting there being, plastic polymer molecules.
That's it.
They're not, there's no big dance going on with those molecules. You might also say that, if you think about what are biological organisms made of, what's inside us biological organisms is this gooey stuff. It's not something like a liquid. In a liquid, kind of molecules just bounce around randomly. Every molecule is kind of like every other molecule. It doesn't really matter where the molecules go. You're just making this sort of homogeneous thing. What has been discovered in molecular biology in the last few decades is that's absolutely not how biological organisms work. Biological organisms have these very orchestrated configurations of molecules, where there are these very active processes where one molecule will interact with another that will kind of extrude another thing, and it'll walk down this fiber and do all sorts of other things at a molecular scale. There's kind of this bulk orchestration of molecular processes that seems to happen in living systems. And so a thing I've been interested in very recently is, I've been thinking about it for a while, but I managed to make progress recently, is kind of what can one say about a bulk orchestrated system, whether molecular scale or otherwise? What kind of a thing is going on when there is this kind of bulk orchestration? And sort of the thing, this is slightly conceptually complicated. One of the discoveries of physics about 150 years ago that led to this statistical mechanics idea is when you're dealing with molecules in a gas, all the molecules are, they're bouncing off each other. There's a whole complicated pattern of molecules bouncing around and following all kinds of trajectories. None of that matters when you're talking about the overall behavior of the gas. It turns out you can do a statistical mechanics. You can just say, I'm just going to look at averages of what happens to all these molecules. And the result of that is, don't follow all the details, but in the end, the gas behaves with certain pressure and all that kind of thing. So that's a place where sort of there's an aggregate statement that can be made without diving into all the details of what happens to every molecule. Now, in biology, we haven't known how to do that. In other words, if you look at biology textbooks, it's a very reductionistic approach. You're looking at, every page has another thing that people have to memorize, so to speak, because it doesn't make any sense. It's not like there's a big overall arc of how it works. It's just like this particular molecule does this and it produces that and so on. It's a lot of detail about how things work. And the question is there some overarching sort of theoretical set of principles that kind of overlays this whole set of details about how biological organisms happen to work, so to speak. So that's the thing that I've been exploring recently, is kind of what is this phenomenon of bulk orchestration, what produces it, and what general things can we say about it? Because in the case of statistical mechanics, where we're talking about liquids and gases and so on, we can say very general things that really are quite independent of the details of, what shape the gas molecules are and so on. There's statements about gases that have nothing to do with that. Doesn't matter. There are these aggregate statements you can make. So the question is, when you have these bulk orchestrated systems, are there similarly aggregate statements you can make that don't depend on the details? So the surprise of a few weeks ago, actually, was that the following thing. So if you imagine all these different possible rules that some system could follow, many of those rules, if you pick a rule at random, chances are the system will behave in a complicated, computationally irreducible way. You'll be able to say very little about what the system does. But if you say we're going to instead have these rules be determined by an adaptive process of evolution, and we're going to say that adaptive process of evolution is trying to optimize some fitness objective, it's trying to achieve some purpose in some sense, then the following thing is true. If that purpose is a coarse purpose that is computationally simple to specify, like, have as many offspring as possible, something like that.
Yeah.
Then it turns out that the fact that there is that sort of coarse objective has consequences for what happens all the way down to the bottom of what rules you end up selecting in this process of adaptive evolution. So in other words, this overall objective kind of grinds its way down to have effects at the lowest level. Normally, if you were just sort of sampling rules at random, you wouldn't have those effects. It's because there's this overarching kind of simple objective that it turns out, and it's completely unobvious to me that this would work out this way, it turns out that the fact that there is this overall objective, even when you're looking at the lowest level of what's happening with these rules, there's certain kinds of regularities that you see that sort of find their way down to these lowest levels. And that's, I think, why you can identify any even microscopic mechanisms in biology, that it isn't the case that biology is just everything everything looks completely random. You can say there are these mechanisms. I mean, I think that the thing that that sort of one's trying to understand what general things can one say about systems that are evolved for a purpose, and the surprise is it doesn't matter what the purpose is. In other words, just saying there is a purpose and it's a coarse-grained purpose. It's something kind of coarse, tells you things about the low-level structure of the system. I mean, a thing to realize about biological evolution, for example, the fact that it works is a consequence of the fact that there is this sort of power of computation underneath and a coarseness of what the objectives are. A way to think about that is if every organism, as soon as it was born, had to be able to immediately solve a complicated math problem, no organisms would survive. It's because the objectives that the organisms are trying to achieve are fairly coarse that it's possible to have sort of enough wiggle room that the organism can survive and can build on this kind of computational power underneath.
It seems to me like
I'm sorry.
No, it's all good. We're getting into good stuff, and I'm gonna going to get into a couple things on what you've just said. And I am going to readdress your Pyrrhic victory, because I think that's actually going to get into the nutshell of a lot of what today's conversation is going to be about. I have a hint where you're going, but I'm going to be more interested to hear it from you. Do you suspect? So yes, and for quite some time you've talked about the potential intelligence in systems that might not be shaped like us or act like us for the purposes we do, like the storm, like the volcano or the black hole or what have you. But let us say that there are systems that seem to have this purpose of not dying, and which seems actually more rational as a purpose than solving calculus. Like if you're a single cell, like I actually think not dying is much more sort of useful than calculus. And because if you can unfold enough complexity, you will solve calculus in time, most likely, depending on the trajectories you head off into. As it seems, I mean, you're out there working on calculus, and a couple billion years ago, I don't think there were entities capable of that. Would you suspect that the things that are, again, I know not of the storm, I know not of the black hole, but there will be things aiming to not die. Maybe they are somewhat biological in some pseudo way. Maybe they are grandly, vastly more complex and sort of are also aiming to persist in their non-biological sense and operating in different parts of the multiverse than we currently operate, as foreign to us as our lives are to sea snails. Do you suspect they are operating on greater and greater scales or strata or complexity of this bulk orchestration you speak of, and that they will continually do that expansion of their bulk orchestration through this coarse grain of do you live or die, do you live or die, do you live or die? So imagine something as far beyond you and I as you and I are above, let's say like dung beetles. Are they still mostly embodying those principles to the best of your knowledge? Like, do you suspect that to be true?
Okay. You are immediately using the terms live or die. That presupposes some kind of definition of being alive. That's a
It does, Stephen. It does. And if I died in front of you, you would know. You would not wonder if I was dead, right?
So the thing is, the only thing that's easy to say it's a lose is if you don't exist at all. Now, what does it mean to be alive as opposed to, this was a thing like Schrödinger pulled this kind of stunt on quantum mechanics by having this kind of, the cat paradox. But he says, well, is the cat alive or dead? That's kind of a stunt because most people think, you can tell if a cat is alive or dead. If he'd said, is this atom in a spin up or spin down state? You could say, well, it could be halfway in between. With a cat, you think there's a definitive, is it alive or dead? Now, as you start to generalize the notion of life, this concept of being alive or dead is a much more complicated concept. In other words,
I'm willing to concede that, sure.
Right. So, I mean, the question that I think you're asking is, if we, let's say we're looking at the level of sort of the level that we think we've reached as humans in kind of this chain of biological evolution. Are we the standout winners? Is it in fact the case that the cockroaches are really, better set up than we are? What you see, even in these sort of minimal models of evolution, is you do see more and more kind of pieces get put. If you define a fitness objective, which is sort of where you can just keep achieving it more and more, so to speak. It's not one of these things where you say the objective is to live for 100 steps and then die. You can get to the point where you nailed it. You lived for 100 steps and then you died and that was the end of it. If you say, I'm just going to want to have more, I'm going to want to sort of live longer and longer, let's say, and I say live in this very idealized sense of simple computational patterns, a very easy to define concept there. If you say that, then it is a feature of computational irreducibility. You'll never get to the top. You'll always be able to go on and build more stuff. You'll always be able to essentially find another pocket of reducibility to live in. And that's a feature of, yes, you can keep on adding more things. You can keep on becoming fitter and fitter according to those criteria. If you say, well, are you generally better that's not really
Yeah,
stayable.
sure. We don't have to be, I guess, normative per se. I'm not a. I appreciate your unwillingness to claim some betterness than the dung beetle, Stephen. It seems to me to be a virtue. There's no romance of magical humanness in your thinking, and I think this needs to be the perspective we take now at the dawn of potentially non-biological life. I admire it. So to your point, okay, let's take away like better. I'll use a term. So philosophy, Spinoza. There's this notion. So for Spinoza, like there's this conatus, which is sort of the impetus of something that's not dead, so something alive, to wish to remain in that state. In other words, to aim to not perish. And so persisting, as it turns out, Stephen, interestingly enough, seems to involve the kind of computational complexity increasing stuff that you've addressed. And as you have said, when things ambulate in the physical world, they develop sentience potentially, and they can play little movies in their head of where the prey went or where the predator's going, et cetera, et cetera. And so magazines of new powers open up. I think about abilities, access to nature. So ability to, you and I, we can use microscopes and telescopes, and I'm not going to say we know the thing in and of itself. I certainly don't, Stephen. But we can at least start to get deeper proxies into maybe what the thing in and of itself is. So we have a greater set of abilities, a greater, we also have culture and technology and all these extensions to our abilities of which the dung beetles do not have. So it seems as though life, the great process we're part of, seems to be doing this thing where it's opening new means of experience, of abilities and access to nature itself. And I might not call humans better, but I might say they have more of that than an individual dung beetle. And as a collective, geez, we do some really cool stuff as a collective. I mean, I couldn't have built this computer by myself. I couldn't have coded Zoom, but here I am with you.
I mean, look, the fact is humans are impressed by what humans do. There are plenty of examples in the natural world, for example, of amazing complex, computationally sophisticated things far beyond the computational ability of our computers or the things we built that just happen in the world. The fact is, we humans say, look at this amazing stuff we've built. We care about that stuff. It's not, I think, there's no sense in which, I think if you start to say, is the stuff we built more impressive than the kind of thing that exists in the, crust of a neutron star or something like this.
Yeah.
I think that's to us humans, absolutely the answer is yes. Unquestionably, the answer is yes. And it's like, I sometimes say this at our company when we build software which gets used by sort of the world of research and development and education and other kinds of places. And it's like, we're putting in these features, and it's like, I have to remind people, we're building this for humans. Like the fact that we're building some color model that is based on, red, green, blue colors. Well, us humans have red, green, blue, color sensors.
Yes.
If we were building our product for the mantis shrimp, it has 15 kinds of color receptors.
Yeah, exactly. Yeah,
we would build a different color model for the mantis shrimp.
Absolutely.
Not of selling software to mantis shrimps.
I feel like I'm selling you here, Stephen, on like, I'm married to hominids. Like, I'm actually somewhat eminently like paramount not married to hominids. So what I'm admiring here, Stephen, is not Donkey Kong monkey stuff. What I'm admiring is the unraveling of access to nature and the general set of powers. Now, when I look at the neutron star and I look at the hurricane, if I leave them to keep hurricaning, I do not know if they will bubble up new magazines of powers that maybe wouldn't have existed if they didn't hurricane. Maybe they do, but if at some point humans
For sure they do. Look at geology on the Earth. Geology is a good example where, the things that exist on the Earth today were the result of sort of geological evolution over a long period of time. It's not the case. You're talking about we can reach more stuff. It feels to us like we can reach more than the Beatles can reach. I don't think, to make one thing clear, there's in the end, what matters to us is things that we perceive. When we say we're building up science, for example, what matters to us, what is science? science is this bridge between the natural world as it is and the things we can understand in our minds. The natural world is doing what the natural world does. We want to find ways to have a narrative about what the natural world is doing that we can understand in our minds. Scientific laws, for example, are the ways that we build up that narrative. It's not the case that science is not about just nature does what nature does. Science is about finding ways that we can connect that with human kinds of things, with what we can understand in our minds. So, the thing to realize is that the universe is going to keep going whether we're here or not, so to speak.
Absolutely.
A lot of sort of what happens in the universe can be, and by the way, sort of the things that happen in AIs are also things that sort of happen independent of us. There's the civilization of AIs kind of happening independent of us. The things that, are most relevant to us are things that intersect with our perception of what's going on. And so I think, when you say we've managed to reach further than these other things, I'm not sure in what sense that's true. We've been able to, the thing that has been the progress of human civilization has been taking more and more of things like the natural world and finding ways to bridge more and more of that to the way that we can think about things in our minds. We've been dealt a certain, the progress of science, progress of technology, a lot of it is we were dealt a certain hand by biological evolution. We are what we are according to biological evolution. For the time being, we're stuck with this kind of biological structure. But then the question is, where can we get to with that? And part of the story of where we can get to is the development of new paradigms, new ways of thinking about things, new forms of abstraction that allow us to think about things that we weren't able to think about before. That's a kind of a way of sort of constructing sort of what we're exploring in my kind of terms, where I think about sort of the set of all possible computational processes as this thing I call the Ruliad. We're kind of progressively exploring more and more of Rulial space as we build more and more paradigms for thinking about things.
Yeah.
We're getting more points of view about how things can work in the universe and abstractly. Yeah. Just as if we send out spacecraft, we're getting more and more sort of places we can take pictures of the universe from. So similarly, there's kind of an abstract version of that, which is kind of expanding in Rulial space and sort of extending, having more paradigms that extend us further and further. I think that's kind of and as in technology, for example, as we try to understand the natural world, part of the story of that is, we have all these devices, whether it's microscopes, telescopes, whatever else, that let us extend our sensory experience to kind of other things that we were not sort of immediately dealt to us by biology, so to speak. So, I mean, I think this idea that we can get further, that our human efforts, our development of civilization have allowed us to get further. They've allowed us to get further in building this bridge between what actually happens in the natural world or in the abstract world and what we can connect to the kinds of things that happen in our minds. And if we said, well, let's enhance our minds, let's make minds that are different from our minds.
Sure.
Well, that's then for you and me, we're stuck with the minds we have. We're stuck with kind of, we can have additions to that. We can have learning that comes from the outside. We can have new kinds of sensory input that are sort of plugged into our existing sensory input. But our internal experience is going to stay as our internal experience. If it isn't, then, we don't have this thread of existence that is us. If you say, well, what does my computer experience? Is my computer experiencing the world in this much richer way than I'm experiencing the world? One might say, quite possibly yes, but we can't get inside the computer to know what it feels like to be a computer.
Yeah. We
can't get inside any other human to know what it feels like to be that other human. It's just that we all kind of project from our inner experience, from ourselves, we project, oh, that other person is a human like us. So we can kind of get inside and imagine what's going on in there.
Yeah, I mean, well, I guess I'm gonna kind of ground what you've just anchored us in, that'll tee up kind of the question we're going to dive into, which is the core of the Worthy Successor sort of series here. But to tee that up, do you see it as, like, some people might say, well, today, the year is 2025. They might say, I believe we have more complexity and sort of richness on this planet of Earth now than we did 3.5 billion years ago. And they might even say, and I think some of that richness be good. Why, person, would you say it be good? Well, there seem to be things that are sentient and having a good time. There seem to be things that are understanding the world in the ways that can kind of build up new structures and ways of doing things, and maybe even species that can experience things in new ways, which could also be kind of good and interesting. And presumably, maybe some grand entity following along in that path would be able to discover things that would be more valuable even than joy, creativity, and love, and the things that we think we've discovered that are the pinnacle of all things. Maybe there's vast magazines of stuff vastly beyond that. And unless something's alive, unfolding, in this sense that sort of at least biological life has started, we wouldn't be able to unlock that. So they would say, it feels like we got more complexity, and it feels like some of that stuff is kind of good. Like it's not neutral that it's not just magma on the Earth. It's actually better than neutral that it's not magma, because magazines of new sort of access to nature, etc., can unravel beyond humans. Not for humans, not to make an eternal hominid kingdom. Nobody listening to this show is married to the eternal hominid kingdom, but the great unfolding of the process. What I'm picking up here is you may say, it is no more complex than it was 3.5 billion years ago, period. Like the Earth's crust doing its cracklings back then, way more impressive than all the coolest, most cutting edge LLM models now. But I would suspect, and I could be wrong here, that maybe there is some value in some of this complexity. In other words, hey, it's neato, Dan, that it's not just magma, it's you and I. Because some of this seems neato. Like, so maybe you would say it's not more complex, but maybe there's parts of it you value. I'd love to get a sense of what you value about where we are now versus when it was magma.
Okay. Notions like goodness and neato-ness are incredibly deeply human notions. Now, one of the things for me personally, I'm a very human-oriented human. Okay. I like interacting with people. I think people are interesting. I'm with you. I'm kind of, and when you say, do I personally think that, and I like knowledge and I like kind of understanding things and so on, these are things which I personally happen to like. If you ask me, can I justify those things on some scientific basis, that those things are somehow fundamentally sort of better than something else? No, I don't think I can. I can say that for me personally,
I don't need a scientific basis. I don't need a scientific basis. Do you consider it to be a richer and better world in the eyes of Stephen Wolfram? All I need to know.
Right. Well, so, I'm glad I'm living in the 21st century rather than,
Same here.
a billion years ago or something.
Yeah.
It's, it's good for me. One thing to understand about the progress of civilization and society, it's a funny thing, because if you think about the things that we think of as purposeful today, many of those things would seem bizarrely unpurposeful.
Absolutely.
Somebody 1,000 years ago.
Absolutely.
And what happens is we kind of live in the moment. We are, we grow up in a world where certain things seem to be worthwhile to us. I mean, one of the things that sort of I've imagined in the past is, imagine in the future, it's a bunch of uploaded, disembodied souls that are the successors of current human existence. And imagine that at that time, there's this box of 1 trillion souls. And to us, from our current viewpoint, it looks like a box of 1 trillion souls playing video games for the rest of eternity.
Yes,
And
yes.
And that seems like, hey, that's a bad outcome. But the fact is, to those souls in the box, that will likely seem like, if you were in them, so to speak, that will seem like as meaningful a thing as whatever we do today.
Totally,
I mean,
sure.
In the past,
sure.
The kinds of things, a lot of kinds of things we do today, a lot of things, favorite example of mine is walking on a treadmill. What a bizarre thing for a person 1,000 years
Extremely
ago.
bizarre.
Why are you doing that? That's you're not getting anywhere. What are you achieving? It's like, well, I want to live a long life. I'm going to, make myself healthier. Why do you want to live a long life? Heaven is good. It's some kind of, there's a chain of kind of justification that is of our time and makes something seem kind of, worthwhile in our time. I don't think there's not an abstract sense in which we can say, and that means
it's always subjective. It's subjective to the things that have subjective experience. You had said meaning and need-o-ness is specific to humans. Let me just give you my push on that. So if you pin a grasshopper down and you slowly pluck off each of its limbs, I think you're a sicko. And the reason I think you're a sicko is I suspect that it may feel that. And it may feel that as not neato. And it's not a human at all. And if you do it with a lemur, you're even sicker. Because it probably experiences even more pain, and it can see its family is watching it get its limbs peeled off, and now you're a real sicko, and it's not a human.
You're projecting a lot of human ethics and morality.
But are we to presume there is no sentience other than with man, Stephen?
No. Look, in times past, people might have said the most important thing about life is to die well.
Sure.
And that's I don't subscribe to that. But that could very well have been in a time when there was lots of religious belief about all kinds of things. It could be that that's your objective. So to this grasshopper, it's kind of like it could be that you can't project these kinds of things.
Oh man, dude, I don't know about this. For you, it's like factory farming. It's just like, I don't know, man. They like it. They like it in there. We don't know what it's just as good as when they. Right?
It's
this
something
is nuts,
where
dude.
You're projecting. Okay, so one thing to understand about kind of ethics and so on is we have a feeling about what we like for ourselves, and we have a way of kind of saying, well, I think I'd like that for everybody else too, and I think that's one of the things that's tricky, I think, about ethics is that in science, it's possible to kind of separate off some kind of, well-defined experiment. You can say, I'm going to study this particular thing. I'm going to ignore everything else. That's really not true of ethics. You end up with, this whole system of how everything fits together. I mean, you might say, oh gosh, the fact that you can be free range and wander around and so on, that's a lot of effort. Wouldn't it be better if everybody could just sit in one place all the time? Now, we then have a theory, but that's not good because, then your health degrades and you'll die quicker and so on. But, this assumes such a pile of kind of things that you and I might very well agree on about the way that one should live one's life and what's good and what's bad and so on. But I don't think, if you're looking for an absolute version of this that's somehow grounded.
I don't need an absolute one.
But I don't think much as I personally would be incredibly squeamish about your grasshopper being, your victim grasshopper. I don't like that. Personally, as a human, it makes me kind of, it's uncomfortable to me to even think about that.
Yeah.
But I don't think if I'm to ask sort of the scientific question of, can I argue that there is something sort of fundamentally bad? Yes, I don't like it. So for me, for my ethics, my morality, it's a bad thing. Can I say that there is something abstractly bad about that? I don't think so, because badness of that kind is something specific to the perception of the human. And, we have, and it's worth remembering.
Perception of the human or perception of the perceiver? Because at some point, there were no Homo sapiens sapiens, right? There were things before hominids, which I hope we can presume had a little bit of an inner movie playing in their head. In other words, maybe it's like you think Homo habilis was just as conscious as a granite stone. I presume you don't. I presume maybe we're assuming some degree of gradation here. So,
Yeah, there are animals eating each other all the time.
yeah,
That's
of
what
course.
happens
So,
in the
so
cycle of life and so on.
with that said, like, it's like in the mind of the human. Well, at some point there weren't humans, but there were things with minds that probably had a good time and a bad time. So I'm not looking for some platonic good that sits in space. I'm just saying there are things that are experiencers.
But you are. You're saying there are things that had a good time. And I don't think it's obvious that a grasshopper has a concept of having a good time.
Well, what about, would we go down to Homo erectus? And then would we go down to chimpanzees? Would we go down to lemurs? And like, where are we drawing the line here?
I don't know.
On things that can suffer.
Yeah.
Or
suffering is a complicated concept, right? It's kind of
sure.
If you say, are there levels of neurotransmitter X in the brain? Are there things that are there stress hormones that are secreted? Sure, there will be, in all the way down the evolutionary chain, if you start doing things to an organism that, you make it run faster, it's being chased by something, then stress hormones get secreted. And you might say, gosh, golly, that means it's having a bad time. Now, let's talk about the human case. If you are, an enthusiastic runner, or somebody who likes to do, high jumps or something like this, you will secrete stress hormones. Does that mean you're having a bad time?
If you hold me down and repeatedly plunge a fork into my chest, we're not going to have this debate. And if you do the same thing with a reindeer, I also don't think we're going to have this debate. Right?
Well, the fact is, what is your objective measure of it's not having a good time? One objective measure would be, one sort of chemically measurable thing is it's secreting stress hormones. Okay?
It's not the line I'm drawing. You can draw it if you want. That's not the line I would draw. But yeah.
Well, okay, but then what is your definition?
Well, here's the deal. So I suspect.
Okay, what's your definition of suffering for a single cell organism?
I concur with your notion. Now, so you had said it's in the mind of the human. I would say it be in the mind of the mind that be experiencing it, and that it be a screaming shame that we don't understand sentience, and that we ought to understand it in some more robust way. So I'm not here to say, here's my algorithm for it.
I don't think you can extend things like goodness and suffering outside of kind of the human concept and context. I think those ideas are deeply connected to things like human culture. I mean, people have said, at different times in history, what would now be considered, terrible suffering was considered a virtuous thing to do.
At what point did that emerge for you? Did this exist at Habilis? Would you have granted this to Habilis, or, the Devonians, or like, at what point did goodness emerge for you?
I think that goodness, in the way we define it in the 21st century, in our sort of portion of society in the world, is just this particular bubble at this time in history.
Was there a bubble for the Habilis or for the Devonians? Did they have a bubble as well?
Look, if you're saying there's this notion of goodness, you and I think we probably agree on a bunch of things that would constitute goodness. Probably, even in the world today, among humans, Homo sapiens, humans, there would be a lot of disagreement about what counts as goodness what counts as not goodness, so to speak.
You're right.
And so I don't think, I think it is a thing of the moment. I don't think it is a thing where you can say we can extend this, a million years in the past, etc., nor even a million years in the future. I don't think the things that we think are morally right today are some of those things. Certainly we've seen in the last, couple of decades, plenty of things that seemed morally right in their time, we later on decide were not morally right. I mean, my example, I'm a person who eats meat, for example. Could very well be that at some time in the future, somebody like me will be considered completely shocking. Oh, he ate meat. That's a bad thing. But today, that's not viewed as being kind of a major moral sin, so to speak.
I guess, limiting it, I don't need it to be static at all. And I would consider something that's good to be the unfurling process that unravels more of the sets of powers, access to nature, and total space of experience Like I consider that process to be a net good personally. So because it seems as
I'm
though
not sure everybody would even agree. I mean,
no,
words,
and I don't need them to. I don't need them to. And so, but where we're headed here is, if there be future minds, and we're going to crack into one other question after this, but this is a very unique perspective you have, and I think it's worth fleshing out so that I and the audience understand it. Maybe, all right, so let us grant that even to Habilis, no, there be no good, bad. If you stab the Habilis in the chest 100 times, who knows? The guy fucking likes it, whatever. It's all the same. Move forward. I would say, let's say we take Stephen Wolfram, or maybe not you because you don't like this stuff, but maybe we take somebody, Jim Stevens, smart guy, maybe not as smart as you, but he's smart. There's brain augmentation developments vastly exceed and outstrip the pace that they've had in the last 20 years. And somehow we're able to bump this person's memory up and then bump up some other capacities and port a lot of his thinking into the cloud. And we can ostensibly, ship of Theseus be like, is that still you, Stephen? Is that still you, Stephen? And maybe it's not anymore, but it's something is in there experiencing something. Stephen is no longer at some point appreciably human. He's not mostly his chromosomes in the way that you and I are. He's not mostly, and maybe it's not even still him inside, but something, there is still qualia in there. He'll have a conception of good, to your point, that may have nothing to do with eating meat or not, right? It's like totally arbitrary, these issues we're dealing with. It's completely different for him operating in this different plane. But to him, there may still be preferable or non-preferable things. In other words, there's a new space of those things which are worth pursuing, those things which seem preferable or non-preferable, those things that we'd like to explore, those things that experience as good or bad, those things worth knowing or that are painful to know or what have you. So this thing, which it not be human, would, it seems, be able to do this thing that you're claiming to be sort of the human thing, which is the goodness lives in Homo sapiens sapiens. It would seem as though up above, from that new vantage point, it would be able to unravel the same processes that you do in your mind and I in mine. And I agree with you, they're very subjective. Would you grant that such an entity could do it? Or would you say, no, beyond us, it's not good anymore?
No, the thing is that you could say the weather has a notion of good and bad. There is something that we could identify that is, we could choose to say when it's not raining, the weather is it's good and the weather is good. But if we take this idea that we can extend our notion of goodness to something very alien to us, that's a complicated idea. And I think that when we have this question, okay, so let's take the thing you're positing about kind of you're digitalizing humans. That they're even I find it interesting to think about these kinds of things. So there are companies now that I've been slightly involved in, which are talking about future brain uploading possibilities and so on. And I had the experience recently. Somebody made a pretty a modern LLM avatar of me because I've yacked enough in
There's plenty of data of you out there for sure.
Right. So it was interesting to talk to me, so to speak. It was actually very disappointing for the following not so obvious reason, which was my team had talked to this thing, right? And they said, yeah, it's pretty good. You should have a conversation with it. Okay. I start talking to it and I start thinking, it's no good at all. It's not like me at all. And it's disappointing to me that people who worked with me for, more than a decade are like, it seems like you from the outside, but from the inside, it really isn't like me. And that's a thing which is a little bit, so it could very well be the case that this thing that's the uploaded version of me, for example, is like to everybody else, it's like, oh, it's just like him. But if I was still around to interact with the thing, it's like, oh my gosh, this thing that's supposed to be me is not really me at all. But anyway, that's sort of a practical side point here. But the question you're asking is, if you take the me and you're gradually, ship of Theseusing me into a digital form, right? So it's gradual
vastly expanded digital form, right? You have 25 senses instead of 5. You have memory, like insanely unbounded memory.
So the me as it is today probably won't be able to have that interesting a conversation with that future thing, because it's that future thing is off doing its own thing. It's like the AIs of today. there's lots of stuff going on. It's like nature, for that matter. There's lots of stuff going on that is sort of computationally sophisticated, that is not very aligned with us. So it's this question of what okay. So now what you're trying to do is you're trying to say, how does the thread of ethics tie back to sort of in that process of ship of Theseusing, so to speak, of replacing more and more neurons, replacing more and more parts of the brain.
Leveling up, augmenting, expanding as well. Yes.
Right. So the question you're asking is, how does my current view of morality kind of map into the view of morality that I would have as this augmented digital version of myself? So that's a reasonable question. I think let's look at some analogies to that question. So, for example, let's look at young children as compared to adults. So young children have a less sophisticated view of the world in many ways. They don't know as much. They can't operate as many things and so on. And they have a view of morality that I think is a little different than the typical adult view of morality. I think that so that's kind of a kind of a microscopic model for what one can imagine the sort of more sophisticated, more kind of more capable, augmented humans' view of morality might be. Now, let's give an example, a morality example. So one of the things probably different between children and adults is the ability to perceive what's going to happen if you do something. So now for us, right now, with our capabilities, we can imagine, we can say, hey, I don't want to do this because that will have this consequence for this other person or whatever else. Okay, let's imagine that we greatly augment our capability to perceive what will happen. Then, how does that then affect our actions today? And how do we make the decision? One of the complicated things is if we say today, I can do certain kinds of things, they will have certain effects. Now let's say that I can do things which have a much broader effect. They'll affect many more people in more complicated ways and so on. And now I have to have some moral compass to decide what those other things that I can do, what consequences they'll have, and how I think about those consequences. So let's give an example. Let's say you have AIs running around and they're running lots of features of the world. And then the question is, and the AIs are very capable of figuring out the consequences of things that they do. There's an AI, it's running the central bank, it's deciding how to set interest rates, it's running all of these different kinds of things. And it can run a really good economic model. Maybe that's computationally irreducible and there are difficulties with that, but it does a lot better than we can do at understanding the consequences of its actions.
Yeah.
Now the question that it comes to it is, okay, I move this lever and I have these consequences for the world. And for example, the rich get richer, the poor get a bit richer too. The forests are destroyed. Happens, that happens. There's a whole collection of consequences. Okay. How do I then decide? Do I move the lever this way or that way? What is my basis for deciding that? And how do I, in other words, I'm this very sophisticated AI. I can understand consequences in a way that we humans cannot at the present time. We humans would just say, well, it looks like the right thing to do. Let's just do it. But let's say that we have much more foresight about what will happen. How do we then decide on, with that additional foresight, how do we decide what we should do? Then we have to have some moral code. Maybe we try and use utilitarianism, for example. That's kind of a losing proposition, I think. It quickly falls apart. And what we realize is it's going to come back to, there's not going to be a thing that we can define that is sort of the right way to do it when you have those enhanced capabilities. It's going to come back to we're going to be reflected back to our present situation and saying maybe how does that reflect on our present situation? How do we maybe extend from our present situation? It's not something where you can say abstractly. I mean, your notion of things that are abstract versions of goodness, what I'm kind of attacking is this notion that there is an abstract notion of goodness. Because that's what you effectively have to have if you're going to extend the notion of goodness beyond our current experience.
I guess what I'm getting at is it seems as though there is no abstract in that it be objective, it live outside of your skull or my skull. But goodness shooteth out of your skull and into the world you observe, and it shooteth out of my skull and into the world that I observe. And things that don't have skulls, but have like minds that shoot out, I would presume to be able to do the same thing. In other words, let's just take you for example. You've got a family who you care about. You have work that's very meaningful for you that you've been involved in for a great many years. And you know, maybe this has dawned on you, maybe it hasn't, have woken up maybe on one random day and be like, man, if it was whatever, half a billion years ago or something, and I was some early form of rodentia, or I don't even know if they were around then, to be honest, whenever early rodentia was around, you're like, I could have had a family and loved them as well, but like, it kind of feels like I can appreciate more about my kids than the rodents could, you know? And it almost feels like the things I do day to day, which in your case would be, you know, creating, Wolfram compute services and all these new launches and products and fun things that you're up to, which benefit other people. It would seem like, this seems richer than what I'd be able to do as a rodent. And it would strike me that you might then take that contrast with the past to now and be like, oof, thank God I'm here, and say, geez, I sort of wonder if there's a state space of mind which would not be accessing eternal goods, but would have a subjective inner experience as I do now, but maybe would be able to love and create in stratospherically more fulfilling and maybe impactful or whatever kinds of ways than you have now as a Homo sapiens sapiens. But it seems as though for you, stretching that far, it's like, no, good doesn't go up there. Whatever that thing is, it doesn't, the good lives with me now. Like it feels as though this is your opinion, but I don't want to put words in your mouth, Stephen.
Well, look, this whole question of alien minds is a long debated and, long thought about philosophical question. Yeah. Okay. So, and it's something where I think that the notion of what is good is something that I think is very much of the moment, of our culture, of our personal experience, and so on. And I just don't think that we can say there could be a similar notion that is transported to some time in the future. I have no idea what the correspondence is between that notion and the notion that we have now. And if you say, we have certain feelings of things that seem like they're good. And maybe we could even measure, this seems like something I think is good by measuring, neurotransmitter levels in my brain or something like this. By the time it's, if we ask an LLM, what is good? Well, the LLM's been trained on a bunch of human content. Yes. It doesn't really count.
And we don't know
but
that one.
If you ask, one of these simple computational systems that I study, you say, what is good for that system? Absolutely meaningless question. I mean, it's something where the system does what it does. You can say, I will attribute in my attempt to humanize what's going on. I mean, it's very common. I see these things going on the screen and their little structures that form and attack each other and so on. And I anthropomorphize those structures. Just as I and everybody else anthropomorphizes their computers. They say, my computer is having a hard time. Well, what does that mean? I mean, the computer is looking like, oh, I'm really struggling. It's, my CPU is burning, et cetera, et cetera, et cetera. The computer is having a hard time. I'm projecting my sort of human views onto that system. Yeah. I just don't think that, if you take, you can describe the computer, like, for example, you were talking about suffering, okay? My computer, like I was doing something yesterday where I'm pretty sure that my human anthropomorphized version would say my computer was suffering. I have 200 cores. They were all running full out. The computer was like, it was having
struggling mightily. Yes.
Yeah. Right. So, but now, and you say, well, okay, then let's talk about ethics. Was it a bad thing for me to make my computer struggle mightily? And you would probably say, not really. That's not, it's kind of what, but now this is where you're going to get yourself in trouble, so to speak.
Go ahead.
Because the fact is that the reason you care, it is because you have certain inner feelings about yourself and you can see other humans, and those other humans seem similar enough to you that you imagine that if you did to them what you know you would not like to have done to you, that has, it has you can feel something about that. I think that's what, human empathy, that's how human society manages to sort of hang together and so on. Now, when it comes to the computer, you don't have empathy for your computer, I suspect. People don't tend to have empathy.
Not at present, because I presume it be not, I presume it be not sentient. And I presume that now, if I were to take a cat or something, it's not just because it has two eyes like I have. It's because I presume that, it could have a good time and not a good time. And you may not. A cat getting stabbed with a fork and a cat, eating a dead fish or something, maybe about as, like whatever. Who knows which one it likes the most? I have a strong hunch. I don't know for sure, but I have a strong hunch. But the computer, I suspect at present, doesn't. The mind I just said, the extrapolated Stephen Wolfram as rodent. Thank goodness you weren't born as one of those. Stephen Wolfram as human, and then Stephen Wolfram as somewhat augmented, different from human, maybe not so alien, but as far up in overall potentia above the rodent as above the human as the human is above the rodent. It seems like even there for you, that thing, like I don't need it to look human. For me, it's like, does it have a wider state space of these powers, and potentially is it sentient? So it's not because the computer doesn't have eyes, it doesn't have neotic traits. I don't suspect it's as much that, Stephen, as it is that I don't think it's capable of a good or bad time at present.
So you think your computer has no inner experience?
At present. I have no certainty on this,
wrong.
But at present.
I think you're wrong.
All right.
I think that in the definition of, what does it mean to have an inner experience? For us, we know what it feels like as humans to have an inner experience.
Sure.
And we can extrapolate from that kind of inner experience. We tend to extrapolate that to animals, for example, higher animals at least, that they have an inner experience. We probably don't think that an amoeba has an inner experience. We do think that cats have an inner experience. Cats have the same kind of neurotransmitters that we have. Cats are really very similar to us in many ways.
Well, absolutely.
And I think that in this notion of, what does it mean to have an inner experience? I mean, again, I could argue, what I've been arguing about, sort of that to know that you have an inner experience is a human thing. And, to say that the computer has an inner experience, it's kind of a human choice whether you say that the computer has an inner experience. But I don't think there's a bright line that says a computer doesn't have an inner experience. We humans do have an inner experience.
I don't have a confidence in any theory of sentience. I've had everybody from, Sutton to Singer and Bengio, et cetera, on, and I've heard ice cold confidence that all machines are sentient and that they're not. I somewhat sit in the middle, maybe out of ignorance, but I consider your...
But look, here's the problem. You have a word, sentience, okay? Mm-hmm. Words can be defined any way you want. Words are just a way of transmitting a thought from one person to another. That word, the definition of that word, the dictionary, what the dictionary says, you can say, this is sentient, that's not sentient, this is good, this is not good. The question is, what gives teeth to the meaning of a word is what you build on top of it. So, for example, if you say, if it's sentient, then I can't kill it, or it's bad to kill it.
Yeah.
If it's, that's what you have to define, is what, just saying it is or isn't sentient, it's like whatever. You can define it, I can define my computer to be sentient, you can define the computer not to be sentient. Who cares? The question is, as you start building on top of that, what are you trying to build? Where are you going with the question of whether it's sentient or not?
Yeah, well, and again, it's not that the meaning hasn't also been vehemently debated with these different people from different angles. I mean, they're not. I don't think they're all ignorantly hurling a word and suspecting everybody shares it. But I'm with you.
I'm saying that just defining the word and saying, with my definition of sentience, the computer doesn't make it. Somebody else says, well, with my definition of sentience, the computer does make it. that doesn't really get you very far. What starts to get you somewhere is if you say, okay, because the computer is sentient, this and this and this is also true, we're going to build some whole intellectual structure on that idea. Then you start to have to say, what do we really mean by it being sentient? Does that mean that this tower can be built, that tower cannot be built? So what I'm interested in is where are you going with the question of whether sort of the future human has a notion of goodness and so on? What consequence does that have? Because I think these things are very definitionally slippery. I don't think you can get, until you start building this tower of consequences, you're not going to be able to tie down what you mean by the future human having a notion of goodness and so on.
Yeah, well, and so this will be super informative as we tilt into the next question around where we're headed. It's this kind of fascinating thing because you're very much in many regards, I think some people would say, oh, cool, look at what Stephen's doing. This really feels like kind of progress potentially, or at least a deeper understanding on certain really important things in the world, or maybe lenses through which to understand the world that might help us do new things with computers, maybe even understand biology in interesting new ways. And I think many people who are frank about nature are pretty open to the fact that we don't understand enough about intelligence. There may be deeper things there. And of course, there's the economic contribution of the companies you've built, et cetera. But at the same time, it seems as though for you, it's like, well, yeah, Dan, I'm doing all that, but it's not progress. The world is the more I understand, it's just me as a silly human understanding this little pocket. But there is, even as a subjective person, we all are, you have things you prefer, don't prefer, or whatever. And as you've said, many of those things are arbitrary. The eating of meat, what have you. These things will come in and out of fashion. As you look forward to the world and the unfurling process of kind of complexity and computation that you articulate well, we can kind of talk through your lens here. It seems as though you do see some degree of inevitability of the processes that went from kind of the cell to us, maybe not through the exact path, like, oh, it was always going to land on us, but that it was going to do this lumping. You talked about your stone wall. It was going to be doing that. Now, as you look forward into the future, I will ask you to state this as you, not as some objective sort of observer of the good for all of eternity, but just your hunch, because you're doing so much work that clearly there are some futures that you feel like that would be kind of, for me, Stephen Wolfram, it would just seem better. And maybe it's anthropocentric. You're looking through monkey goggles. I'm looking through monkey goggles. It's anthropocentric. But you say, I like those futures better than these futures. And you're working on the things that, again, many people would define as progress. And I think there's a kind of humbleness to the fact that you're almost very swift to deny the littleness of what we define of as progress, which is cool. But you're working on certain things. When you look at the unfurling process as it continues to unfurl, now presumably at some point, Homo sapiens sapiens themselves won't necessarily be the main steering force, and maybe we're not even now, but we won't be the most, let's say, relatively powerful species of entity or what have you. But the process unraveling, other substrates are maybe taking on certain traits that only biology did back in the past, and things keep on unraveling. If we go forward far enough on that, maybe even to a point where there's not that many humans around or whatever, what would be the versions of that unfurling process that you would say, this is not objective good, but Stephen Wolfram, I think this trajectory would be better than this one. In other words, is there a better for you for this unfurling process we've been talking about, just from your perspective?
You kind of definitionally kind of sunk yourself there, because what you're saying is that there aren't humans around, things are happening in the universe, but there aren't humans around. Is it good what's happening in the universe? And what I'm saying is the definition of what, let's peel back a few things. So first point, I have lots of subjective opinions about what I want to see happen in the world, what I think would be cool, et cetera, et cetera, et cetera. Mm-hmm. The question is, am I under an illusion that those things in some sort of ultimate arc of the history of the universe have some fundamental significance? I wish I could say, yes, those things have a fundamental significance in the history of the universe. I don't think they do. I think that they have a great significance to me personally. They might have significance to other humans and so on. But in the long view of the physics of the universe, the galaxies are going to go on doing what the galaxies do. The black holes are going to go on eating things up, et cetera, et cetera, et cetera. It's not, we are the little bubble that is the things we do there's no sort of fundamental thing that we're achieving. I don't think, we are achieving things which are subjectively very significant to us. But, what I think you're asking, I mean, you're saying, are there better paths that sort of the world could go on or not go on? And for example, here's an example of a very obvious question. Is it good if humans go extinct? Simple question, right? Is that good? Is it the right thing for humans to go extinct? Let's talk about the morality of humans going extinct. Now, one problem is that morality is defined by humans. And if there are no humans, it doesn't really have a meaning. It's something where we can say, as we look to the future, do we think it is morally right for humans to go extinct? And I think we're going to have a hard time having that question have much meaning. And I think that now you can ask, is it the case that if what happens is that, the future of humanity is a bunch of uploaded souls sort of playing video games for the rest of eternity, does that seem like a good outcome to me, for example? From my point of view today, it's like, well, actually, it's very ironic for me personally, because, a lot of my life has consisted in exploring the computational universe of sort of all possible computational processes. And if you imagine what would those uploaded souls be doing for the rest of eternity, there is, in fact, an infinite space of the computational universe to explore. So in a sense, for somebody like me personally, it's kind of an ironic outcome, because I'm saying the thing that I've spent, the last half century of my life doing.
This is the interesting thing. Yes. It's almost working against it, right?
It could be the infinite future of humanity. The future of humanity is the exploration of the computational universe. And that's what those uploaded eternal souls might be doing. Now, that's do I think, is that a good outcome? I don't know whether I can put as a good versus bad outcome. It's a kind of ironic and interesting outcome. I think it's kind of it's a curious outcome, but I don't think, if you say, is that an outcome where I would say is the outcome? Let's take some more basic outcomes. Let's say that our civilization is sort of the achievements of our civilization are digitally encoded to the point where the AIs can do lots of the things that we do, can produce lots of the kinds of artifacts that we produce and so on, can fashion things out of the natural world of the kind that we do. And then we say, what about those pesky humans? Are those humans really contributing anything? Because these things that humans have produced externally, so imagine humans are all in boxes and you can't ever see what the humans do. Imagine that there's this kind of, every human is encased in a we're all Darth Vadered and we're all inside these boxes, but you can't actually see the human inside. But to the world at large, one is still all these Darth Vader humans, or Daleks. I think Daleks were another sort of form of, there's a critter inside, but it seems like a machine on the outside. There are these humans in boxes, okay? The world is operating. Things are happening in the world. Great paintings are being produced, all sorts of things, but you can't see any of the humans. All that happened, it's kind of a Turing test-like thing for things happening in the world. All that you see is a bunch of boxes that are doing human-like things. Now the question is that a good outcome? And, can you start projecting current human morality onto that outcome? Because the world is operating as the world operated before, maybe even better than, in some sense, than the world operated before. If you knew that there were humans inside those boxes, you would say, great outcome. Humans are living a happy life. They're doing, they're singing and dancing and painting great paintings and so on. But then, if you say, well, let's imagine that scenario. It's kind of an interesting scenario, I think, of where you can't tell there are any humans. It's just, you're looking at it from the outside. It's a bunch of Daleks, operating, the Doctor Who Daleks or whatever, which I think had critters inside in the end.
I have to Google this now, but anyway, I'm sure some of the audience is familiar. Go ahead.
Okay, all right. Well, it doesn't matter. Think the kind of
Yeah,
Darth Vader,
exactly. With a living thing on the inside operating it or whatever,
right.
from what you're saying. Yes,
But you can't tell there's a living thing on the inside.
yes.
Right. I think then then the question is, let's talk about the morality of that world and the goodness of that world. Because now I say, I'm going to pull the rug out from under you. I'm going to say, actually, none of those boxes have humans inside. The humans all died out. Those boxes are just AIs that were some kind of human engrams, human trained things that were going on and doing human-like things into the future. Now the question would be, well, how do we think about, is that a good outcome? Is that something where we say, and I think you would say, well, that's in your projection of goodness, you would, I think, have to say that's a good outcome. The things that are happening in the world, great paintings are being painted, et cetera, et cetera, et cetera. Lots of good things are happening in the world. Unfortunately, we humans went extinct. Now, to some other people, they might say, look, if the humans went extinct, that's disastrous. Everything good has been destroyed when the humans went extinct. But yet, to your operationalized view of what's good in the world, the world's going on and wonderful things are happening, just happened, the humans went extinct. So I think, the point I'm making is it's sort of very difficult to, as you project a notion of kind of morality, goodness, whatever, into an environment that is different from the one that we are experiencing, that we have our inner experience of today, I think it's very hard to make any extrapolation there. I mean, I think it's very hard to say, I kind of like this scenario. I hadn't thought of something like this before of the, all the humans are in boxes, so to speak.
Daleks, yeah.
And, right. And but the world is going on and great things, to the outside, great things are happening. It turns out in the end, there was a rug pull and there are no humans anymore.
Well, I'll clarify a little bit of your take here, and then I'll clarify what you had said about kind of like, hey, Dan, by your view, this would be the case. I think you're basically there. I'm just going to clarify a little bit of like where I actually stand. But to clarify where you're standing here, it seems like for you, hey, if there are futures that I, Stephen Wolfram, am contributing to building, you're inventing technology, you're employing people, you're raising a family, you're doing things that people would say is, oh, this seems like things he thinks is good. Stephen thinks those are good things, and clearly you do. And I think, again, I don't know if they're objectively good. Are they good to the black hole? Are they good to the universe? I don't know, but it seems like for you they are.
A meaningless question. That's a meaningless question.
Totally. So for the futures, the possible set of futures, it almost seems like, from my vantage point looking in, and you may surprise me here, but some of what you're saying makes me feel like of the panoply of possible futures, only the ones where direct lineages of Homo sapiens sapiens exist, or actually Homo sapiens sapiens as they are. Because I do want to be clear on one thing. Humans going extinct is certainly, well, it's not something I would advocate for, but I think often we are a process. You and I are a metabolic process. And again, there was Erectus before you and I, and then there's something else. So I think there's also a bit of gradualness here, which could be through biological and non-biological means. I'm not looking at just brute extinction. I'm looking at slight change. And now you might say, when our genome shifts beyond a certain threshold, no longer be there any good, I might say that thing might actually have some vantage point of good. But regardless, when I see the futures you might look at, you would say, look, the futures I would aim to move us towards would be ones where people are really still in them, because who the heck knows what's good if it's not people there? So you'd be looking for human-oriented futures in some way.
No, I mean, look, there's a question of what, in my life and the things I try to do, I certainly have a strong value system about what I would like to see happen in the world.
Yes.
However, if you ask me, is there a from the outside objective way in which I can justify my value system? The answer is no. There isn't. I could make up a bunch of stories about why my value system is the best value system. That's been a story of human society throughout history. People have said, my value system is the best value system.
Because this.
I'm going to kill everybody who doesn't follow my value system, or whatever else it is. Or I'm going to turn my nose up at other people who don't follow my value system. That's been but I don't think, I would not make the claim that my value system I very strongly believe for myself in following my value system. But, I'm not going to argue that in an abstracted version of things that my value system is in any way better than sort of fundamentally better. Now, there are features of value systems, like, for example, the value systems that cause humans to go extinct. The question is, do you like those or do you not like those? Some people would say, I'm more concerned about what happens to the planet than I am concerned to what happens to humans. And look, the humans are doing all these terrible things to the planet. The planet will be better off without the humans. Morally, I think the humans will be better off. It would be better for the humans to be extinct and the planet to have a happier time, whatever that means. I mean, I think that's a very bizarre, I think that's, that's something that's a very, people will say that, but that's part of, I just don't think, I think it's one of these things where, for example, this question of suffering of your computer. You say, I don't really know how to think about that. I don't know whether my computer
I don't have a sense of confidence in it. I don't have a sense of confidence.
Right. But so what I'm saying is these things where you're projecting far into the future and saying, what do the uploaded souls think is the right sense of morality? Those things are, I think it's just something that isn't really defined. It's no more defined than it's defined. For example, if I switch off my computer, is that morally wrong? And, the way that starts to be morally wrong is, for example, can I switch off the internet? Would it be morally wrong to switch off the internet? It would be practically lots of, problems would arise, but is it morally wrong to switch off the internet? And, that question, in that particular case, it gets entangled. Let's say, is it morally wrong to switch off this chatbot? Well, that's an interesting one, because the chatbot could have formed a relationship with all kinds of humans. Maybe there are humans who didn't even know they were talking to a chatbot. They thought they were talking to another human. And then you switch it off. It's like, but you just killed my friend. And that seems like something that's very morally wrong to do, even though all you actually did was to erase the bits that corresponded to the network that was that chatbot.
Well, okay, so I guess
I'm sorry. I'm just these kinds of you're poking at a bunch of philosophical arguments, and I think it's
it's perfectly fine. You're not answering incorrectly. You don't have to apologize for anything. You're laying out your vantage point in a coherent way. I'm enjoying it. So there's no, and I'm sure the audience is liking your opinion because they're pretty damn unique, which is why you're here. So let me just lay out when you had said sort of, these machines that might have something living, and there was nothing living inside of them, or no humans inside of them. I'm not going to lay out an opinion that you should agree with, or I'm asking you to agree with. I'm just going to lay out an opinion that one could have that I think is not without the smallest lick of credence. I think it could be one of the ideas on the table. So this idea would be that there is something good. So you had said, is there anything that I do that would be kind of cosmic significance or whatever? I'm not going to say fully cosmic significance, but let me posit this. It seems as though the unfolding process that has expanded the total set of powers and access to nature, et cetera, that has bubbled up not only sight and flight and hard shells and the internet and everything else has sort of emerged from this unraveling process. It seems to me that this unraveling process has given rise to the set of things that even could be good. To your point, there's no one good thing necessarily, but there's something alive over here that thinks this is nice and this is bad. There's something alive over here that thinks this is good, this is bad. And maybe for you, that's just Homo sapiens that feel that stuff, and it's not the things after them or before them. But whatever. This process, and I do think it's somewhat honest to admit ourselves to be part of a process. There were things before us, there'll probably be things afterwards. This unfurling process seems to be what undergirds Stephen Wolfram's notion of the good and experience of the good. You've had great times in your life. It seems to be probably what undergirds the goods that may exist in other potentially living things. And it seems as though if that process were to continue to unfurl and a wider state space of possible goods were opened to other subjective things, and they could continue to unlock new understandings of nature, maybe computation space like you have, or other sorts of domains and approaches to sort of the sciences in the world, that experience could become wider, understanding of nature could become wider, set of powers could become wider, and maybe there would be something that would have a galactic level impact in terms of like shifting that environment. Maybe there would be something that would figure out physics in some way to zip around through wormholes or go into other dimensions and do sorts of things that might actually borderline on a cosmic impact. And so it would seem to me that if there was something with a cosmic impact, the undergirder of that which permits subjectivity and which could unfurl into a kind of power which could be at a cosmic level seems to be the great process. And that the things that are conducive to the growth of the great process maybe would be as close to an objective good as we could have. I'm not going to call it objective good, but it would be as close to an objective good as we could have. What would you say to this vantage point?
Well, I think okay, let's say we have my computer I say my computer understands something about nature that no human understands. What does it mean for the computer to understand it? What does it mean that it's one of these things which, untethered from human minds, the concept of understanding is kind of meaningless. And a lot of these things you're saying about, we can have, we have the problem is, it's not that I say, what I'm saying is the notion of something like good is tethered to our current culture, our current existence, and so on. I'm saying that there are things in the world that are kind of abstract. There are things there are things about computation that we can think of abstractly that don't depend on our particular instance of anything. That a notion like good, I think, is not one of those kinds of things. It's something that is kind of a contingent concept that depends on our nature to define it.
Complexity had to bubble up to us to even conceive of it, did it not? Did the archaic conceive of the good? You think they didn't. I think you're right. So in other words, the complexity bubbling up did undergird and birth the notion of the good, right?
Okay, so that's a complicated question. I'm not sure I think I know the answer to that question. In other words, the issue is, let me give you an example.
Okay.
Think about the notion of intelligence or the notion of life. Okay, let's say defining life. You're trying to define goodness. Let's take a simpler problem, perhaps, to define life. Life on Earth is pretty easy to define. There's no life on Earth that doesn't have RNA in it, that doesn't have proteins and so on.
Yeah.
Life on Earth all has a historical lineage. We go to random planet X, we scoop up something from its ocean, and then we ask, is it alive? It doesn't have any RNA. It has other kinds of things going on. I have this slight suspicion that from this whole things I've been doing about bulk orchestration and so on, that there may be some sense in which we can detect kind of a thing where there's sort of been a progressive building of what's been going on, a progressively greater level of orchestration that's happening. I haven't thought that until quite recently, that it's possible that there would be some concept, something a bit special about life, as opposed to just this sort of something that is, random molecules floating around in the ocean on planet X. So, but I mean, I think the question is, let's for life, we're trying to get a definition. What the heck is life abstractly? And people have had a very hard time coming up with that. I think we're maybe beginning to see a little crack, little ray of hope in thinking about bulk orchestration, of having an abstract definition of life that is beyond just saying, oh, life is something that has, I don't know. Well, I remember when I was a kid, the first Mars landers were going out and they were scooping up soil from Mars. And the question was, could you tell if there was life in soil on Mars? And what they did was they fed the thing sugar and they tried to see whether it produced carbon dioxide. And that's the
litmus test. Yeah. Yeah.
Right? And which is obviously, we know now, that's a very kind of crazily, Terra-centric view of
Terra-centric, Gaia-centric, whatever, right?
Yeah. Right. Yeah. I mean, I think that, this question of, even what's life, what's intelligence, we can define, I would claim that the abstract definitions of intelligence wind up being just about computation. But there's a definition of intelligence that aligns with human intelligence, which is, again, tethered to humans. And I think this question of, is there an abstract notion of something like good that isn't deeply tethered to humans and current human culture? I just don't think that's a thing I don't know how to define that. I don't know how you define a notion of good that transcends the current features of humans. Just like I haven't known, I'm beginning to maybe possibly know how to have a definition of life that transcends the details of life on Earth. And so, I mean, I think, maybe there is some way to give some kind of definition. I don't know what it would be. To me right now, all I can see is there's it's something that's tethered to humans as humans are today. So, when you say what, I suspect you might want to go in a direction of there's this possible outcome. Is it better than that possible outcome in this notion of good? And what I'm saying is that's when those outcomes are distant from the way we are today, that's really something that it's not possible to define. At least I don't know how to define that from what we have today.
Understood. Well, maybe let me end on this note, because I think you've put together kind of a coherent view of your abstaining from that outside of direct 21st century Homo sapien experience. You are working on things which I think many people would call good in ways, maybe not in some eternal Platonic sense, but maybe good in ways that they think could be relevant in a slightly grander sense than even just purely humans, but things like understanding life. I think, to your point, it is still a little bit goofy that our definition of life is as silly as it is, and coming up with new conceptions of how to detect it and understand it and ask how it behaves and does what it does seems really important. I have this idea of it's important because if we could understand it, we could conjure forth that autopoietic self-creating process. And for me, the expansion of that flame rather than the eternal locking to any one torch is important. But again, that's not your vantage point, and I'm not asking for it to be. But you're looking to understand life. Kind of why? Like, if you got it right, what would it permit you? Go ahead.
Yeah, let me stop you there, because I mean, it's kind of like it's the ultimate colonization. It's like we are the way we are now. Let's go colonize the universe. Let's go take the way we are to us right now. I mean, for me, I would say if we can spread humanity as humanity is now, spread it to the galaxy. That's cool. That would be I don't know whether I would say it's I don't know what what I would think about its morality or whatever, but I think that's a thing that is a worthwhile aspiration for humans, to, spread humanity throughout the galaxy, let's say. I mean, difficult thing to do, but
absolutely, yeah.
I mean, it's always interesting to think about, if you've got that starship going off and, there are 20 generations living inside the starship, the chances are the people who walk off the starship at the other end are going to be nothing like we are today. In other words, the culture that's evolved there is going to be something so alien to what we have today that we would not actually think of that as being a successful spreading of humanity as we imagine humanity today.
Great point.
I mean, but so this point about, it is egocentrically, anthropocentrically satisfying to imagine that we spread what we are today, throughout the galaxy or whatever. That's a fine thing. I'm all in favor of that. That's really cool. Can I justify that in some objective sense? Absolutely not. Do I personally think? Do I think spreading our species to other planets would be a fine thing to do? I don't know how practically useful it is.
Yes.
To my life. I mean, in other words, if there was a Mars colony, how would it affect my life? The aspiration of there being a Mars colony does affect my life. I think it's really good to have the aspiration of having a Mars colony. Does the practicality of a Mars colony, the made on Mars, the Mars bar that was made on Mars or whatever, I'm not sure I care about that. Maybe I'm missing something about how that works. Yeah. But it's something where it's something where you can, again, it's this question of, to us today, what difference does it make? And then, is there a more global sense in which you can say there's a good thing to have happen? And I'm making the claim that there really isn't a more global sense in which that it is, you can say something amazing happened there.
So to wrap, I guess, on your own notion of progress here, just to kind of close out, you're figuring out what life is. on some level. You're at least trying to chip away at that. And maybe this grand notion of the Ruliad, which may tie to, Kant's thing in and of itself in some way, may provide some lens of wisdom into Kant's thing itself. You're doing that. Like, what would you articulate as the reason? Some people would say, man, Stephen's really contributing. But you are, again, you're interestingly humble about how fettered our conceptions of contribution really are. But if you were to say, Dan, I'm working hard on this, here's why. Is it simply, I like it. I like doing it. Is it, Dan, I hope this impact comes of it. Is it, Dan, like, what is that for you? Because you work hard and diligently for many years.
Yeah, right. I like doing it. I happen to get fulfillment out of other people, having a good time with ideas I create and technology I create. That's a form of fulfillment. I mean, it's I don't know why. I can't really explain the fact that, I get a warm, fuzzy feeling out of people having ideas that I've come up with and absorbing them and having a good time absorbing them. I can't explain that. I can't tell you objectively why that's a wonderful thing, but it is my internal perception is that I like that. And I would say that I could argue that I think it's become it's maybe it's going off a little bit these years, but a few years ago it was the Silicon Valley thing was you have a meeting and instead of let's dedicate this meeting to the greater glory of God, it's this meeting is about making the world a better place. That's sort of the modern version of that. We're going to make the world a better place. I think that's I wouldn't yes, that's a fine thing. It gives me a warm, fuzzy feeling. Can I claim in some objective, external reality that's significant? Not really. I mean, I think that's, we all have to, I could paint you the kind of chain of, the things that I'm trying to do of understanding how the universe works, building technology, finding pockets of reducibility that represent inventions. I think one of the things, so this is maybe one thing to end on, is, part of what it means to invent things, part of what it means to discover things in science, it is, in my view, finding these pockets of computational reducibility. And those pockets allow us to kind of jump ahead. If we were stuck in this morass of computational irreducibility, we'd achieve very little in our lives. Our experience, our span of experience, however many years we have to experience it, would be much less rich than it is if we can kind of jump ahead with all of these inventions and so on. And I think that's the thing. If one can say, what objectively are we achieving from progress? What we're achieving is that in the span of a finite human life, more can happen. That's kind of an abstract notion. I mean, that's kind of what I think a lot of sort of the progress of economic value, the progress of knowledge. It's about in the span of a human life, kind of more can happen. I mean, just maybe to say one last thing. I mean, I think in terms of the as we imagine, let's say that we could extend the span of our minds. Let's say we are extending our minds so that we are encompassing more and more different points of view about the universe. We right now experience the universe from inside our brains, with our eyes looking out. We've got a bit of technology that lets us see a bit further out in the universe, a bit further across the world and so on. But fundamentally, we're experiencing things from within ourselves. As we gradually can extend our senses, can extend our view of the world, we're sort of gradually expanding our minds to the point where we can encompass more about what's possible and what's happening in the world. I think one of the, again, sort of Pyrrhic things that has to happen is by the time, if we could extend sort of throughout the Ruliad, if our minds could span this whole Ruliad, if our minds could span all computational possibility, well, that's in a way, that's like, wow, we made it. We span the whole Ruliad. Problem is, I don't think we coherently exist at that point. I think that coherent existence is a feature of the particulars of some entity that has some sort of set of coherent characteristics. By the time we are everything, we're in a sense, almost definitionally, we're nothing. By the time we span everything, we don't have a sense in which we are, we are these individuals, we are these entities that we can identify as coherent things. So that got very cosmic.
No, it very much did. Well, it's a great note to end on. And Stephen, I'll end on this note to tie a bow around it. I think, you're adamant about being able to define things. Again, an admirable thing. I'll say, even if you can't define the warm and fuzzies that you get from people enjoying your ideas and aiming to build upon them and have fun with them and maybe make that kind of leaping progress that you hope to make and see in the world, even if we can't define it, I still appreciate it. And I'm glad that you feel it. And I'm grateful we were able to do a little bit of it today, Stephen. So it's been a real joy to have you. Thank you so much for being here.
Sounds good.
So that's all for this episode of The Worthy Successor here on The Trajectory. A big thank you to Stephen Wolfram for joining me again on the show. And thank you to you for tuning in all the way through to the end of this very unique Worthy Successor episode. Few people understand and have thought about complexity as much as Stephen has, and many of his ideas really were quite surprising. So I have quite a good deal to kind of cover here in the post-interview reflection that I'll sort of put back on the table, and would be very much interested in your thoughts in the comments down below. I'm sure we have a great many Wolfram fans. I know on Twitter, this is the episode people have been knocking on my door and saying, when is it going live? So a few things that sort of come to mind as we kind of dive in. Essentially, everyone we've interviewed here for this series, and maybe even outside of this series, I think has sort of seen intelligence and sentience as a kind of spectrum of minds. That is to say, a fruit fly, pretty questionable on the sentience side, pretty questionable on the intelligence side, pretty questionable on the moral relevance side. You start to get up to like a naked mole rat. You start to get up to, koala bear. You start to get up to a chimpanzee. You go to humans. It's sort of, there's a gradation on some level of the intelligence, sentience, relative amount of kind of powers that can be conjured from these entities, and potentially their moral value on some level. For Stephen, that this was very much not the case. Sort of the defining anchor of this episode is kind of two things. And one of these things Stephen mentioned to me kind of after we cut the microphone and when we were just kind of chatting after the episode. One of them is that, so for him, there's no real appreciable increase in complexity from the molten ball of magma that the Earth was, 4 billion years ago, whenever it was, to literally today. And no increase in complexity in an appreciable way from, 1820 till now as well. Because to Stephen's point, the bubbles of magma and sort of the shifting of those early pre-tectonic shapes kind of blobbing their way over the early spheroid that we now call Earth may have sort of been doing computation and sort of behaving in complex ways that are just as sort of complicated as everything that we do now today in modern society. Again, I think appreciating complexity in everything is something that Stephen does, and sort of seeing how it plays itself out in ways that seem smart, ways that are complex, that maybe most people don't see. Obviously, very much a virtue of sort of his general approach. The non-extension of that into sort of being able to just frankly say, hey, this grand expanse of human civilization with all this technology on top of it, et cetera, really not appreciably different than, in terms of complexity or moral value than the magma, incredibly unique. And I'm going to go into sort of where that was quite confusing to me, and also why I think maybe given his mindset it does make sense. So I'll get into that. The other thing Stephen mentioned off microphone, as I believe he had said when he was young, I think his mother taught at Oxford, and he was in the room as a young kid with a bunch of philosophers all the time who all had great highfalutin things to say about what we should do and morality and this and that and a bunch of things that we couldn't really measure. And for him, he was like, I got to measure things, and this is the mindset I'm going to have in the world. And so for him, it was also a little bit of a pushback against maybe too much of a talk about values and morals and things like that, and too little of a grounding in sort of the quantifiable, which I'll bring up a little bit later, is very much a defining element of this interview and of Stephen's thought. So let's roll into the rest of what we have here for notes. There was this really, really interesting juxtaposition going on in this interview between what I would almost consider to be a kind of brute anthropocentrism and a sort of totally like almost transparent eyeball objective view on nature, which wasn't necessarily tinged with brute anthropocentrism. Here's what I mean by that contrast. So let's just address it. The idea here for him was that sort of the one value that kind of matters is kind of human preservation, and that sort of value is relative to us. It's relative to our little pocket of reality, and that value didn't exist maybe even a couple hundred years ago, and definitely not to let's say Homo erectus. So sort of like literally we come to this random point in clock time where Homo sapiens sapiens as they are now exist, and our current value sets exist, and now things matter in a moral sense. In other words, goods and bads can occur. But there were no goods, there were no bads backwards, and there will be no goods, and there will be no bads forwards. I'm not putting words in Stephen's mouth here. You can listen to the episode. I'm simply giving you my interpretation, and I'm sure there's more nuance to be had. But that strikes me as a sort of almost transcendently anachronistic and anthropocentric take on sort of like what the good could be. But that's contrasted with the fact that Stephen, again, sees richness, interestingness, an equal curiosity in nature with the moving magma and, the hurricane and some cosmic events, as he does with what we see with humans. He does not believe that there's some sort of special sauce that makes us special and amazing. We're sort of one of these many patterns that are sort of carrying forth through the cosmos. The way that it seems to me as though those two things click together for him is that the good is not really tangible. And so, yes, we may be a pattern, but we are this pattern. And so we can say what seems good or not good to us. Stephen talked about things he likes. He likes teaching people. He's got a family. He has things he enjoys. And we can say that in this little sliver of time, that's it. And I think that's how it's rectified. We'll get into the issue of measurement in a minute, but I think that's the way it's rectified. Very interesting juxtaposition. I found it hard to follow, but I sort of do see how it fits into his grand and sort of cosmic view. Again, he has a very unique worldview built from a lot of time thinking about these things. What was really surprising to me was sort of the notion that, like sentience itself has no bearing in sort of the moral sphere. I don't think I've ever interviewed anybody who would say if you put a human in a cage and you peel their skin off, that would be suffering. But if you did it with a Homo erectus, it would not be suffering, or would not be suffering that would in any way, it wouldn't register on any moral scales. Nothing wrong with it. Nothing wrong with it. That sort of a trillion factory farmed cows and a single dandelion are like exactly morally equivalent, like exactly the same. There is simply no register whatsoever for the difference between those two. I've never heard it, never seen it, never had it come up in the show. And I think again for Stephen, there's all this complexity. It's kind of equally complex. Magma bubbles, you watching me right now, exactly the same in terms of like raw complexity and sort of specialness in terms of complexity. And again, I think there's probably a lot of wisdom there, even more than we could get into in this episode. But that the slice that we live in as humans and what affects us, that is the only accessible good, period. I find this harder to be tenable personally. And again, Stephen also mentions like the good must be quantified. How do I quantify the suffering of these cows? Maybe they like it. You know, there were some comments where I was like, whoa, man, like I almost fell off my chair probably 3 or 4 separate times in this episode. If you saw me continue to stay seated, it was using like massive muscle groups you couldn't see, stabilizing myself. The emphasis on measurability, I think is a very earnest thing and is warranted. In fact, isn't it frustrating that we can't quantify suffering? In fact, isn't it a shame we can't quantify suffering? Those of us that believe that it is morally, it registers somewhere morally, whether for humans, like Stephen does, maybe humans alone, modern humans alone, or some people who maybe think that, you know, the suffering of a cricket or a field mouse or, you know, an elephant might also be relevant. It really is a shame we can't measure these things. But it seems as though it is possible. So that this is sort of what felt like the difference between some of how I think about these things and maybe some of what came through with Stephen. Number one, I certainly didn't have any parents teaching at Oxford and was not growing up around philosophers. I had only books for the first 25 years of my life to speak to philosophers or really very smart people at all. So I didn't have the same rebellion against the moral as maybe Stephen did from sort of growing up in that ilk. And certainly not his life trajectory of sort of robust focus and sort of mathematics, etc. But I guess I would say it seems to me that one can point through the state space of what is and what is kind of becoming, and even if something isn't entirely quantifiable, like there isn't a single algorithm to describe it, that one might consider it preferable to something else. Maybe preferable for oneself. Maybe even preferable in sort of a civilizational sense. Maybe preferable for sentient things that maybe I can't jump in the mind of a cow, but it would seem to me there's some ways to treat a cow that are just probably not good, to be frank. You know, I don't have to be a cow to sort of look in its face and hear it make noises and be like, that doesn't seem like a good time. So it seems to me as though we can proxy those things which are morally valuable. And sort of move closer to them, even if they can't be completely quantified top to bottom. Again, I think that lens is probably outlandishly useful. You know, if you're going to write Mathematica, you probably have to think that way. I just found it to be tough to square. Similarly, it seems to me that all is process. That is to say, we humans are just part of a rolling and unfolding process. And you know, in many ways, Stephen knows this better than anyone in the world. I mean, the sort of, the cellular automata and sort of an understanding of emergence in all these interesting and robust ways, sort of unfurling and unfolding. The interesting thing for Stephen that really came through in this episode is that none of it for him is more complex than the previous stages. I don't know if I agree with that. And there's been a great many people with Stephen level IQs that have been on this show, the one you're watching, who would think that sort of there's higher levels of emergence and potentia expanding from systems than there were before. And it seems as if things are all becoming, then slicing what the good is to now feels somewhat limiting in terms of thinking about what are the directions that could be good. And you've heard on this show from a Nick Bostrom to a Peter Singer to a Micah Levin. None of these people are like paramount Nimrods, right? These are like reasonably intelligent people. I think most people would agree. You've heard them paint. What are the things we'd want to see manifested more of, right? We are more of X than the Homo erectus and then the field mouse. There might be things that are more of X than humans are. This seems to me to be, if all is process, then considering a slice of value would mean there would be components of that value that could blossom more into the future, or could have situations where they crash into situations of less into the future. Being unable to touch on that in this episode was extremely bewildering in some regards. But again, it was tantamount to Stephen's worldview, which I'm not calling wrong. I'm simply calling extremely different from what we've normally covered here. Very, very, very different in many, many, many different regards. There was also a point here where Stephen talked about kind of the potential where maybe sort of humans playing video games forever could be kind of good. Like for all we know, we zip up into some little uploaded hoopla, and we're playing some goofball video games for eternity in some sort of uploaded state, and that maybe that is kind of as good as it gets. My disagreement there sort of fits in with the other comments thus far stated, in that when we are outside of the stream of life, that is to say, the emergent unfolding process of becoming. You've heard Blaise Aguirre-Iarchis talk about symbiogenesis. You've heard John Smart talk about autopoiesis. You've heard Michael Levin talk about the cognitive light cone. Lots of intelligent people have had words for this. But there's a way of contributing to the net complexity and set of powers of the great system of the process of life, where one can add to that great process. And in my own mind and that of some of the people we've interviewed, that would be a kind of contribution. And that would be maybe even a way to ensure persistence. If we think about Richard Sutton, if we think about Brian Swim, there have been people who've talked about how you kind of have to be bobbing and weaving. Nature, Richard Sutton says, nature is sort of constantly beckoning its entities to become what they must become in an ever-changing dynamic system of a universe. And that sort of as you become and contribute to that, that is what will allow you to persist. It is not only good for your continued persistence that you continue to do that, adapting and contributing to the net set of powers in the unfolding process of the stream of life, but it's sort of in your own, it's in your own interest, and it's in the interest of the greater system. I think that a zipping up into a little sugar cube of mental upload to play video games would sort of be very much a stepping out of the stream of life. It would be stepping out of the participation in an unfolding of greater degrees of complexity. And I think that is what I've come to as kind of maybe a core divergence from Stephen's episode here and many of the other episodes we've had in Worthy Successor, that for him, again, there is as much complexity at all stages. You know, in any way, shape, form, and direction, there's as much complexity. It isn't really being gained. You know, this human civilization, airplanes flying in the sky, billions of human beings, these devices sitting on my desk doing gajillions of computations, you know, GPU farms, you know, football field size that are solving new protein folding problems that have never been solved before. This is all just as complex as the lava flows. Again, there is almost certainly a tremendous amount of wisdom in that just as complex side of the house. But I think I tend to see it as a more complex. The lava, in so much as I presently understand it, was not thinking very much about what it was becoming. It was not able to bend its trajectory of unfolding new kinds of power and potential to continue the unraveling process of life. And life seems to be doing that. That seems to be very, very different. And I think that divergence is sort of the major difference that we saw in this episode. And again, hopefully it came through as quite cordial. I was rather surprised by what Stephen said, but I was open to listening to him and hearing what he had to say. And his ingredients and the mix of this conversation, I consider to be worthy ingredients to this conversation about the Worthy Successor, even if some of them were bewildering for me. I think I know where he was coming from, and I think that locus that I just touched on, that crux, I think was sort of, in a somewhat ultimate sense, where the difference lies. It may be the case that all this complexity that we bubble forth is sort of just dissipating other kinds of even vastly more complex things that we're not aware of happening at the femto scale, for example, in the Ruliad, to use Wolframian terminology here. But I do believe that some degree of emergence and greater ability to sort of unfold complexity and power and keep the great process of life alive, to unfold things like consciousness and possibly beyond consciousness, that itself be value. And again, Stephen had a very different opinion, but an opinion that was worth having in the discourse regardless. One thing that can be said about Stephen, like some of the other thinkers we've had on here, his opinions are no one else's but his own. Like Stephen does not speak a bunch of lingo that exists on the forums or on Twitter. This is Stephen Wolfram's thought. This is a very deliberately built, structured way of looking at the world. And I think hopefully for many of you, there will be a lens of it that will apply meaningfully to how you think about the world, whether it be in innovation, in regulation, or just understanding this wacky process of intelligence that we seem to be a part of. And I was very grateful to be able to have Stephen on this episode and be able to join us and throw a real wrench in the gears of sort of the normal discourse that we have here. So again, Grateful for him, grateful for you to tune in all the way through to the very end of not only the episode, but my end cap dialogue here. Without further ado, we'll wrap on this one. I'll catch you on the next episode of The Trajectory.